A equals 1/2 times 4 times 6. We simply substituted into the equation. So we call that the substitution property of equality. Sometimes we'll use this for congruence. In this example, we used it for equality. So we're giving an example for the equality version. Okay. In the book, you'll notice it has these nice charts with all of these summarized. So understand there's another place where you can find these. 2 different pages in section 5. Okay, friendly reminder, the distributive property, we are going to make sure that we say that we use this. The distributive property, you use it all the time. You take the number on the outside and you multiply it by both things inside the parenthesis. All right, let's try one of these. If I gave you a problem, 4m minus 8 equals negative 12, and asked you to solve for m, you would know that your first step was to get rid of this guy by adding 8. So in the first step, 90% of the time, notice I said 90, not 100, the first step justification is given. These blue comments here are just as important as the algebra. We're saying why we know it was okay. In this equation, this was the given equation, so you just write given. In the second step, we added 8 to both sides, so we say addition property of equality. Again, you can use your abbreviation here. I honestly don't necessarily need you to write these down, guys. We're going to practice tomorrow. Just follow along. Then we're going to, after we add 8, we're left with 4m on the left side and negative 4 on the right side. We just call that simplify. Think for a minute, what would you do next? Trying to get rid of this 4. We're multiplying it, so we're going to do the opposite, or divide by 4. So we say division property of equality. After we do that, we simplify, and we get m equals negative 1. And that's the final answer. Okay, let's try another one. If I give you an equation, a given equation of 1/2 t equals negative 7, how do you get t by itself? Some of you may be thinking right now that you divide by a half because we're multiplying, but let's remember that we never divide by fractions. We multiply both sides by 2. When we multiply both sides by 2 over 1, we're basically multiplying by the reciprocal of 1/2. Okay? To get rid of a fraction, you multiply by its reciprocal. Multiplying this side by 2 and this side by 2, the justification or the reason is multiplication property of equality. When we do this, we're going to simplify. This side, the 2's cross off, and we're left with t. This side, 2 times negative 7 equals negative 14, and we've come up with our answer. Okay, this next example, this formula should look familiar to you. I'm going to go ahead and write the given equation here. This is the conversion between Fahrenheit and Celsius. You probably have used this in science class. Again, this is the given, so your first justification is given. If they tell you that it's 15 degrees Celsius and they want the Fahrenheit temperature, this tells you to put the 15 or substitute the 15 for the C. So in the next step, we're going to copy the formula. Remember, formula, substitution. This substitution, we only know C, so we replace C with 15. Doing the math here and simplifying, 15 is over 1. We can make this 15 over 5 into a 3. 3 times 9 is 27. Okay? If you're using your calculator for this and you're going to do 9/5, you need to hit 9 divided by 5 first, or use parentheses, 9 divided by 5, end parenthesis, then times it by 15. Either way, you're going to get 27 when you do that. We're going to add 32, and we're going to simplify again to get 59. Remember, we always put our units when we're finished, so our final answer is F equals 59 degrees. The next example is when we are given Fahrenheit and we need to convert to Celsius. We're going to use this version of the equation. Not that much different. We just flipped the fraction and we subtract 32 now. We're going to, of course, start with our given. In our next step, substitute. This time they gave us F, so 86 goes here. Notice the parentheses require us, PEMDAS tells us to subtract first. Then we're going to multiply by 5/9. 86 minus 32 becomes 54. We've only simplified the parentheses. When you do this on your calculator, again, you need to take 5/9 by 5 divided by 9. 5 divided by 9. You can use parentheses before and after the 5/9 to make sure you're always doing it the correct order. Parentheses 5 divided by 9, end parenthesis, times 54. And you're going to get 30. We put our units and we call it 30 degrees. Okay, just a reminder, don't forget your geometry. We're going to call upon this segment addition postulate, the angle addition postulate, and several definitions. We're going to make ourselves a nice summary sheet to use for the rest of the semester, actually. We're going to spend some time doing that in class tomorrow. Let's try one that involves the segment addition postulate. If you're only given this picture, then what do you do first? You write small part plus small part equals big part. Small part is NM plus the other small part is MO equals the big part, which is NO. You should be writing SAP or segment addition postulate when you write the formula. As you can probably figure out by now, the next step after formula is substitution. We're going to substitute what we see in the picture. Our NO, or the big piece, is 4x minus 4, so we put that there. Our NM is 2x, and our MO is 3x minus 9. The rest involves algebra, so I'm going to go through this kind of quickly. When you combine like terms, and you don't do this something to the equal sign, notice we didn't add or subtract from both sides of the equal sign. We just combine like terms. You need to use the word simplify. In the next step, we're going to subtract 4x from both sides and add 9 to both sides to get x equals 5. Okay, the next one is an angle addition postulate. I'm going kind of long today, so I'm going to kind of go through this quickly. First thing is to write it out with letters. We call this the formula of angle addition postulate. The next one is to substitute what we see in the picture. Again, we have big part equals small part plus small part. I know it's kind of small, but they told you over here that the big angle was 8x, and that's why we substituted that in over here. Simplifying by combining like terms, we get 9x minus 11 on the right side equals 8x. Subtracting 9x from both sides, so we call that subtracting property of equality. We get negative x equals negative 11. Dividing by negative 1, we get x equals 11. Notice they put multiplication property of equality here. I'd be okay either way. You're either dividing or multiplying by negative 1. Okay, the last example, following example 4 in your book, is to take each of these statements and tell which property you're using. Okay, it's basically mostly applying the last 4 on your paper. So get your notes out and look at those last 4 that we used. If I just say this, if I just say that angle QRS is itself, remember, it looked in the mirror, saw its reflection, we call it reflexive property. Then you decide what is the symbol between them, and since it's congruent, we say reflexive property of congruence. You will get taken off if you put reflexive property only, or if you put reflexive property of equality. The next one says if the measure of angle 1 equals the measure of angle 2, then the measure of angle 2 equals the measure of angle 1. All we did was flip these. Remember, when you flip something, it's symmetrical. Symmetrical property of equality, because that's the symbol we're using. The next one is if A equals B and B equals C. In other words, AB, segment AB congruent to CD, segment CD congruent to segment EF. You should notice this is the law of syllogism. Notice the repeating part in the middle here, and then we finish by saying AB is congruent to EF, or P is congruent to R. That's called the transitive property of congruence. And if we say 32 degrees equals 32 degrees, we're using, again, the reflexive property. This time we call it equality. Okay, hopefully you have your notes filled out. I'll see you tomorrow.